Hello everybody, this is a video about types of data. This is the first lesson in our new unit, which is data management and probability. I've included in Google Classroom a fill-in-the-blank worksheet that you can use to write in some information as you go through this lesson/video. So please print that out before you start watching and fill it in as you go. But remember, it is a video. Please pause it if you need to, or go back to review something if you need to, or if you need more time to write. Okay, on we go. Our learning goal for today with types of data is to explore different types of data, of course, along with some real-world examples of each. We actually use these types of data all the time without really thinking about what they are, how their uses might be a little different. No, you don't have to write down the learning goal. Okay, the first type we're looking at is categorical data, or data. You can have a debate amongst yourselves, grade 8s, as to which way is the best way to pronounce it. Either way is fine with me. So categorical data can be grouped into categories or groups based on characteristics, and this information is qualitative. Okay, so if you remember back from science, qualitative observations are talking about things that you would typically see with your senses. Okay, not numerical data. All right, so examples of categorical data include hair color, gender, nationality. It's answers that are not really numbers. So here's an example of a graph that includes some categorical data. Okay, so it's asking for the nicest fruit. So apples, oranges, bananas, kiwi, blueberry, and grapes. Of course, this graph is nonsense. Everybody knows apples are the best. Blueberries. Okay, now, yes, there's some numbers on the sides, but you're counting the categories, how many people would be in each category. All right, so that's one kind of data. Moving on to the second kind, that is discrete data. So that's data that can be counted, but can't be subdivided. All right, and we'll talk about that. Will become clearer as you look at the examples. So discrete data is quantitative, so you're looking at numbers. Okay, so examples of discrete data are number of people, number of parts in a box, or a number of home runs, for example. Now, when we talk about number of people, that's often the best example of what discrete data is, because clearly you can't really subdivide people. Okay, so you could have one person, two people, three people, four people, that kind of thing, but you don't normally have 1.5 people, or 2 3/4 people, or 3.1415 people. Okay, so you have a specific number of people, and this graph represents that. So you have number of families along the horizontal axis, number in a family in the vertical axis, and so if there's so one family has 4 people, 2 families have 5 people, that kind of thing. Also, one other thing with discrete data, when it's graphed, it's usually graphed in this sort of a fashion, either using bars or dots that are not connected, because you don't want to give the implication with discrete data that you could have numbers that are halfway in between, which is what happens with a line graph if you connect all the dots. So normally that's not done. Okay, on to the last one, and that's continuous data, and that's data that's measured and can be subdivided. Okay, so it can be any value, usually within a range of values. And I'll talk more about that in just a second with the examples. And these are also quantitative, so dealing with numbers. So remember the difference between qualitative, which was their categorical, using your senses to find that information, and quantitative, which is counting or measuring something. So examples of continuous data include heights, time in a race, or temperature. Okay, so it's clear I'll use heights as an example. Now you can have a variety of heights, so someone could be 5.5 feet tall, or 138 centimeters tall, or 140 centimeters tall, or 141.2 centimeters tall. You can subdivide these numbers as much as you want, and it's very possible that someone will be that height, for example. Now, also, you would typically have them in a range. So, for example, you wouldn't talk of heights of a person as being 18 feet tall. You would normally have a range of normal human heights. So it could be any value. So if you were recording heights, for example, you could have any value within a certain normal range of heights. You would not normally have any possible number being used for heights. Okay, just as an example. And this graph is, it's a little bit silly, but it emphasizes the point here about continuous data. And so typically when you see continuous data in a graph, you do see a graph that is connected the whole way through. So line graphs are often continuous. Okay, so you have time along the bottom, distance from the top, but both time and distance can be subdivided into smaller and smaller parts if you want them to. You don't only have things at 11 o'clock and then 12 o'clock and then 1 o'clock. As they're driving, they are getting certain distances away in between those times. So they're moving a certain number, a certain portion of a mile per hour, a certain portion of a mile per minute, for example. But again, those can be subdivided as much as you'd like. Okay, so please try out the attached worksheet, carefully read the instructions in Classroom so that you know what to do, and please email or ask any questions during our weekly meetings. Thank you very much.